Every second, millions of questions are typed into a small search box. People search for restaurants, research topics, product reviews, directions, and answers to everyday problems. The action feels simple. Type a few words and receive results instantly. But behind that small interface sits one of the most complex information systems ever built: Google Search. On the surface, Google appears to be a tool for finding information on the internet. A user enters a query and a list of links appears within fractions of a second. The experience feels almost effortless. But the system behind that moment operates at an extraordinary scale. Before a search can return results, the platform must first map the internet itself. Automated programs known as web crawlers continuously scan billions of web pages across the world. These programs move from link to link, discovering new pages and updating existing ones. The information collected during this process flows into massive data indexes. You can think of these indexes as enormous libraries containing structured information about the web. When someone searches for a topic, the system does not scan the internet in real time. Instead, it consults these pre-built indexes to retrieve relevant pages instantly. But indexing alone does not solve the hardest problem. The challenge is ranking. If millions of pages contain similar information, which ones should appear first? In the early days of the web, search engines struggled with this question. Many systems relied mainly on keyword matching. Pages that repeated certain terms frequently often appeared higher in results. Google introduced a different idea. Instead of only analyzing words on a page, the system also evaluated how pages link to each other. If many websites link to a particular page, the algorithm interpreted that as a signal of importance. This concept became known as PageRank. By analyzing link structures across the internet, Google could estimate which pages were more authoritative. Over time, the ranking system evolved into a highly sophisticated set of algorithms evaluating hundreds of signals. These signals include page relevance, site quality, freshness of content, and user interaction patterns. But the ranking system is only part of the platform. Behind Google Search sits an enormous infrastructure of data centers distributed around the world. These facilities contain millions of servers processing queries every second. When someone performs a search, the request travels through global networks to the nearest data center where the query can be processed quickly. Speed is essential. Most searches return results in well under a second. Achieving this performance requires extremely efficient computing systems capable of scanning vast data indexes almost instantly. Yet the search engine does more than retrieve information. It also powers a massive advertising platform. When users search for products or services, businesses can bid for advertising placements connected to those queries. If someone searches for running shoes, companies selling footwear may compete to display advertisements near the top of the results page. This system operates through automated auctions. Advertisers choose keywords related to their business and set budgets for how much they are willing to pay when users click their ads. When a search occurs, the advertising platform evaluates bids and relevant signals to determine which ads appear. The process happens in milliseconds. For businesses, this system creates a powerful marketing channel. Ads appear exactly when users express interest in a topic. For the platform, the model generates enormous revenue. But the ecosystem extends further. Website owners and content creators rely on search engines for visibility. A strong position in search results can bring millions of visitors to a website. Entire industries have emerged around search optimization strategies designed to improve rankings. This creates a complex relationship between search platforms and the broader web. Content creators publish information hoping to reach audiences. Search engines index and organize that information. Users rely on the platform to navigate an internet containing billions of pages. Yet the web itself continues growing. New websites, videos, research papers, and digital content appear constantly. Search systems must adapt to this expanding information universe while maintaining relevance and accuracy. Artificial intelligence increasingly plays a role in this process. Machine learning systems help interpret complex queries, understand language patterns, and deliver more useful results. Instead of matching only keywords, search engines attempt to understand intent behind the query. Even with these advances, the scale of the challenge remains enormous. Billions of searches occur every day. Each query must be interpreted, matched against massive indexes, and ranked according to relevant signals. Results then need to be delivered to users almost instantly. From the outside, Google Search looks like a simple text box on a web page. But underneath sits a global infrastructure system. Web crawlers mapping the internet, data centers processing billions of queries, algorithms ranking information across an ever-expanding web, and an advertising marketplace connecting businesses with potential customers. The modern internet contains an overwhelming amount of information. Google built the system many people rely on to navigate it, and that system quietly became one of the most powerful gateways to information in the digital world.